Alright, let's see if you guys are all paying attention. Class?
Yes.
Alright, so, thank you. I was looking for this because I wanted to hit the Q indicator. As soon as he stares down on his phone again, perfect shot right at the top of his head. Yeah. Chow. There we go. Anyway, alright, so we're going to continue with yesterday's lesson. So, everyone that wasn't here, make sure you wrote 41 on these notes. And we are down to minimum spanning trees. Now we have a tree and we have some weights to it. We have some values for each one of the segments. So minimum spanning tree for a weighted graph is a spanning tree with the smallest possible weight. Smallest possible weight.
You have pencil?
Yes, I do. This thing better return directly to me if I find it on the floor, okay? Me and your aunt going to have a conversation about your phone not coming back to you.
That's crazy.
I know, she just messaged me.
For a pencil?
Yeah. I'm hating that much right now. Because yesterday, I went through a whole box of pencils yesterday because people just either take them, leave them on the floor, or, yes, would you like a pencil too? Will you promise to bring it back? Your aunt has not contacted me, so that's why, you just get to promise to bring it back. I don't have to threaten you. Or do I have to threaten you? Do I? No? Okay. So, now, I know everyone makes sure that their earbuds are off and away, right? Even if they don't understand the words that are coming out of my mouth, okay? Tu earbudos. Gracias. What are they called? Audífonos. Audífonos. All right, so no matter how cold it is, you got to take it off too. Thank you. All right, so I made that guy, so please, thank you. All right, so again with this, minimum, smallest number. What if it said maximum?
The biggest number.
It would be looking for the biggest number for each one of these. From spanning trees below, we see that C has a smaller weight than B. By weight, that means we're taking each one of the pathways from the two that we did earlier in yesterday's notes. We had this one right here where I was able to remove that section, and the weight there was 12. So as we add up all of my links, I get 119. But by including this one and removing this one over here, right here, I have a weight of 107 now. So in between those two, I had my original, which was this one over here. Then these are the subgraphs. These are the graphs that I did with removing one piece. Okay. Minimum small. Is this the minimum spanning tree, or should we continue to find other possible spanning trees that may have total weight less than 107? Okay. Is there another way that I could do this to have a smaller value? By looking at just my graphs, I know that I want to use the smallest numbers. I want to use the smallest numbers. Smallest numbers. Smallest numbers. Okay, smallest number here. Is everything connected? And then there's only one going to this. So that one right there would be the smallest version of that graph. So the 107 is going to be the smallest. All I do is I have n minus 1 edges. So we said that when we did this last time, we had 8 vertices, and we have 7 edges, or 7 bridges, or 7 roads connecting those. Hirschkuss algorithm. I hate doing this guy's name. It's horrible. Anyway, procedure for finding minimum spanning from a weighted tree, weighted graph. Find the edge with the smallest weight in the graph. If there's more than one, pick one at random. Mark it in red. So what I just did, I just marked it. I picked the next smallest one. Okay, at random, mark it. Find the next smallest, and keep going until all vertices are connected and I have my correct number of edges. All right, blah, 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 blah. Okay, here it is here. So we're going to use Couscous algorithm on this. So each one of these vertices, so I have 1, 2, 3, 4, 5, 6, and 7. I have 7 vertices there. How many bridges am I going to use? 6. I'm going to use 6 bridges. So 7 vertices, so n equals 7, so it's 6 edges. Bridges, either way. Now, in the process, it says start with the smallest one. What's going to be the smallest one here?
Starting at 242. Where are we starting?
242. Anywhere.
Oh, we're starting in G.
Anywhere. I'm just anywhere. I just find that 242.
Yeah, 241.
G to F. All right. What's the next smallest? There's another 40 something.
Wait.
There's 245, right? Yeah, there is a 245, so that's good. So there's the 245. Okay, and then the next one after that would be 249. Okay, would I use 251 though? What would 251 create?
What's it called?
That would be a circuit, wouldn't it?
Yeah.
So do I want to use that one?
No.
No, that's perfect. So I cannot use this. I cannot use that because that would create a circuit in between these other ones.
Yeah.
Okay, there's another 251 here. Okay, right here. So could I use this one here? Yeah, okay, so no circuits.
Oh, wait, that's the one I was talking about. When I said 251, that's the one I was.
Oh, I'm sorry. Okay, but yes, I thought you were smart there for a minute. You were, you just didn't realize it.
All right.
Yes. So you called the 251, but there was also 251 that I can't use over there.
Yeah, I didn't see that.
I'm trying to give you credit for it and called you smart.
Go ahead, go ahead,
Okay,
go
good.
ahead.
Anyway, what am I going to use next? 253? Okay, so 253 is right here. And now,
Oh, wait,
is
that's-
everything connected?
That's connected.
Is everything connected so far? No? No, we got
Wait, no, E's not connected.
E is not connected, right? So how many edges did I use so far? 1, 2, 3, 4, 5. So how many edges do I have left to use? One more, and I still have to connect. I have to connect E, right?
Yeah.
So that's going to be
259.
259.
Good job, Peter.
They're all connected. I used the proper number of edges. And by doing that, I went through and identified any issues that I had, like with my 251, creating a circuit. And it would have been the same over here with 255 if I would have tried to select that one. But now, what's going to be the minimum? What's going to be the weight on this one? It's add them up. Add them up. So it's, let me see, 259 plus 253 plus 245, 249, 251, and 242. Add those up for me, please. Because I know you don't have your earbuds in because you are doing what you're supposed to be doing, right? Especially if you sit in the front row. That's the worst place to do it. What'd you get? 1,400. 1,499. You guys agree?
Yeah.
This is pretty easy. Hopefully for those people that are following along, paying attention, this is actually pretty easy though, right? Yes? Anyone have any questions so far of what we did with couscous algorithm?
Pretty sure you say goose cow.
But, you know, you can't have Emperor's New Groove without couscous. So, here's another bigger one. Okay, this is where we add it all up, and guess what? That's it. Is that pretty easy now? So, I'm hoping you actually get something out of this. Now, you can finish up the homework for this. Make sure everyone likes, shares, and subscribes. Okay, follow my channel, support my channel, buy stuff from my merch store.